Okay, so here is another voltage divider design problem. So it says we have a 3-resistor voltage divider. So that's a little different. So we're using 3 resistors. For a 12-volt power supply to have 2/3 of the voltage after the first resistor and 1/3 of the voltage after the second resistor. Okay, so let's just draw that. So we've got our battery, got 3 resistors, and this is 12 volts. And so what we're looking for is we want to have 2/3 of the voltage here. So 2/3. So if I have all of the voltage here, then I want to have 2/3 after the first resistor. This means I need 1/3 of the voltage dropped here and 2/3 of the voltage here. And then it says, and have 1/3 of the voltage after the second resistor. And so then this is also going to be 1/3 of the voltage. Okay, so let's think about this. If we're dropping 1/3 of the voltage across each of these resistors, that tells me that the resistors all have the same resistance. So that's very nice. So I know then that R1 plus R2 plus R3, B3 plus R3, doesn't want to help me out there. There we go. Plus R3. I guess they're all equal. So let's erase that. Equal. There we go. Okay, so they're all equal. So that sounds pretty easy, right? So what if we pick, we could pick 1,000, we could pick 400. So let's try 400. Let's say we pick 400. See what that does for us. So if I want to figure out, then let's pick the bottom one. So R3 is the bottom one. And so we're going to say, what is the voltage across R3? So V3 is equal to the total voltage times the ratio of R3 to the total resistance. So that's going to be, since they're in series, R1 plus R2 plus R3. So we've got, in our case, 12 volts times 400 ohms divided by 400 plus 400 plus 400 is 1,200 ohms. Right, and so that tells us that we can cancel the 12, so V3 is equal to, we can cancel the 12s, and I'm left with 400 over 100, or 4 volts. Okay, so if I drop 4 volts across this one, I'm going to drop 4 volts across that one. So that makes sense. So I'm going to have 8 volts here. So I'll have 8 volts and 8 volts. So 8 volts over 12 volts is equal to 2/3. So that checks that box. Now let's just check the current and see if we're okay on current. So I'm going to have the current is equal to V over R, which is equal to 12 volts over 400 plus 400 plus 400 is 1,200. And I'm going to get 1 milliamp. So that worked out pretty well. 1 milliamp is a great current to have. No, it's not dangerous or anything like that. We want it to be under 10, so we're good to go.